greatest mysteries of our times. Could we make contact with alien beings from another world?
Open the door! Two down here!
There's two very mutilated small bodies.
Right here, right here, right here, right here.
They only had like 4 fingers.
Big break, big break.
They had very large heads.
Most people are not going to panic.
What are you doing here?
We have in our possession a flying saucer.
Are we alone in the universe? Or is the galaxy teeming with alien life? Scientists once thought these questions were unanswerable, but today they are being solved for the first time. The result is a revolution. The galaxy may be filled with living alien worlds, but could we contact them? And could they communicate with us? Would the first sign of alien life come via radio signals traveling through space? Or could aliens have already devised technology and spaceships capable of traveling to Earth? How should we respond if aliens do reach our planet? What would they look like? And how would they react to us? What can science tell us about alien contact? For centuries, the existence of alien life has been debated. It is a question that may be asked on many worlds. Mystics and philosophers have sought the key to the universe, searching for signs of life on distant worlds. Life as intelligent and curious as we are. Beings who look to the skies in solitude and wonder. Searching for signs that finally answer the universal question, are we alone? On Earth, the dream of alien life seems to materialize in July 1947. A small New Mexico town becomes the center of a bizarre episode in American history. The Roswell incident, the supposed crash of an alien spacecraft that half a century later still is cited by millions as proof that we are not alone. Roswell is a farming town that happens to sit in the middle of America's top-secret proving ground for advanced weapons, rockets, and aircraft. Nearby, at Trinity Site, the world's first atomic bomb is tested in 1945. A month later, a crew based in Roswell flies the first nuclear mission. Now, on Independence Day, 1947, it is Roswell's turn to be the center of intrigue. That night, during a desert rainstorm, ranchers north of the town hear a roar louder than thunder and see a flash brighter than lightning in the summer sky. Mac Brazel is one of the witnesses. He is a foreman on the Foster Cattle Ranch. The next morning, he rides out to check for storm damage. His neighbors, Loretta and Floyd Proctor, will never forget what happened next.
We were good friends and neighbors. He helped us and we helped him, and we visited with him a lot.
Riding with young D. Proctor, Mac Brazel makes an astonishing discovery.
And they would get out and ride all day round over the range, you know, checking everything. And that's when they came up on this, whatever had fell there.
It is a scattering of metallic debris strewn across the ranch land. Lightweight, flexible, and extraordinary. Brazel brings back some scraps to show the Proctors.
And he said there's also some material there that had purplish pink. He said it wasn't flowers or it wasn't Japanese writing or anything like that. It was, he said just purplish pink deals on it. He didn't know just how to describe it. My husband and Mac Brazel, they'd strike matches and try to burn it, and it wouldn't burn. He described the other material. He said there was a shiny foil looking that you could crinkle it up in your hand and then it'd just straighten out. There wouldn't be any wrinkles or anything.
The Proctors advised Brazel to take a few fragments to Roswell. The airbase authorizes sending a pair of intelligence officers to the Foster Ranch. One of them is Major Jesse Marcel. Marcel and his partner find a trail of wreckage nearly a mile long. They load their vehicle with samples to be examined on the Roswell base. When base commander Colonel William Blanchard sees the evidence, he calls in his public relations officer, Walter Hout.
I became aware of this Roswell incident when Colonel Blanchard called me into his office and told me that we have in our possession a flying saucer. To put out a release and deliver it to the local news media.
The intelligence office of the 509th Bombardment Group at Roswell Army Airfield announced at noon today that the field has come into possession of a flying saucer. The disc was recovered on a ranch in the Roswell vicinity.
But there is an even stranger part of the Roswell story that is not reported to the newspapers. The discovery of another crash site where the bodies of tiny, unearthly beings are found.
Right here, right here, right here. It's off in the front.
One of the few surviving witnesses is mortician Glenn Dennis.
It was in the afternoon sometime right after lunch. I got a call from the base. The man said he was a mortuary officer and he needed some information that how many baby caskets did we have in stock that were like 3 foot 6 inches or 4 foot. Then he wanted to know, if I called back later, wanted to know what embalming fluid chemicals contained, what would it do to the blood, tissue, stomach contents, and what was our procedure of making removals of bodies that had been laying out in the elements.
Driving an ambulance, Dennis visits the air base that afternoon and gets a chilly reception.
Anyway, I went back to have a Coke, and I saw this captain standing there beside the door. And I said, "Sir, it looked like we had some kind of a crash, so I need to get ready for it." And he wanted to know who in the hell I was, and I told him I was from the funeral home that we had the contract. And he said, "Wait right here, don't take a step till I get back." Well, about 2 minutes later, he came back and he had 2 MPs with him. And he told them that to get me off of the base, that I was off limits and I shouldn't have been out there. As we were going down the hall, there was a door open in this supply room. And this was this nurse that I knew quite well. She had a towel over her face and she was gasping for air. And she saw me and she said, "Glenn, get out of here as quick as you can."
The next day, Dennis meets the nurse again and hears her story of the autopsy of 2 of the alien bodies.
These gentlemen were in there. She said they were from Walter Reed Hospital in Washington, D.C. And she said there was 2 very mutilated small bodies, very mutilated, that looked like ancient Chinese to her. And then they described that the heads were real large. They were pliable like a newborn child, that their eyes were very large, that they didn't have ears like us. They only had 2 ear canals. They didn't have a nose or a bridge like we do. They had only 2 orifices there. Mouth was only one, just like a little inch split. This is the way she explained it to me.
But the story cannot be confirmed. According to Glenn Dennis, the nurse mysteriously disappeared a few days later. One more link in Roswell's strange chain of events. Then, the military commanders suddenly changed their story. In Texas, General Roger Ramey announces it was a weather balloon, not a flying saucer, that crashed at Roswell. But Jesse Marcel is unconvinced.
Jesse Marcel, Major Marcel that is, was my neighbor a block away here in Roswell. Major Marcel, until the day he died, contended that it was not anything other than something from outer space.
In 1947, most Americans accept the Army's explanation. But many in Roswell, including Mac Brazel, do not. The Roswell debris came from a top-secret detection device using balloons to monitor nuclear testing in the Soviet Union. Mortician Glenn Dennis, however, is convinced the government is still not telling the truth about the Roswell incident.
We definitely know there's a cover-up. There's too many things that happen that they keep denying, that there's too many first-hand witnesses. Several of them still alive.
Today, few scientists believe that a spaceship bearing aliens crashed in New Mexico in 1947. But one fact cannot be disputed. Roswell has become a symbol of the human yearning for contact, raising all the questions that science is attempting to answer. Do extraterrestrial civilizations exist? How would they travel? What would they look like?
3, 2, 1, 0.
As we marvel at the stars in their hundreds of billions, we must wonder if someone, somewhere, is watching us. Or if we on Earth are the only winners of a long-shot cosmic lottery. Today, questions once thought unanswerable have become urgent and real, turning science fiction into scientific quest.
If we can prove that there was life on Mars, and for that matter, may still be life on Mars, I think it has to change our worldview.
It's also likely that the steps leading up to the original life, and even the original life itself, is a fairly common process in the universe.
It could very well be the case that there are alien astronomers on these planets, around these other stars, looking back at our own solar system.
When the day comes that we do detect an extraterrestrial intelligent radio signal, over time it will change our world in marvelous and wonderful ways beyond our present imagination.
It could be that ET, for reasons known only to him or her, is deliberately targeting Earth with a signal, sending a rather powerful beacon our way to say, hey, look, here I am, join the galactic club.
It is a revolution in science. The eternal mystery has become the focus of a very modern quest. Exploration that seeks to discover that may be on the brink of discovering that intelligent life is either an earthly accident or a fixture of the universe, that we are not alone. From our world, from any world, the search for intelligent life in space is a complex puzzle in multiple dimensions. Stars themselves are easy to see and count, but life-giving planets are far smaller and harder to find. It is one of the most compelling riddles in all of science. The search for the existence of other beings who not only think and build, but who also dream and wonder. A question as old as humanity and as young as any child.
I first became interested, in fact fascinated, with the idea that there might be extraterrestrial intelligent beings when, at about the age of 8, my parents told me that there were indeed other planets in space. Until then, I thought the Earth was the only one. That was a shock to me, but also it tantalized me. I wondered if, in fact, on those planets there were creatures like ourselves with different histories, different anatomies. It was a terribly exciting idea.
In 1961, as a young astronomer, Frank Drake began a revolution, transforming the search for intelligent life on other worlds from mystery to mathematics.
In 1961, I put together the Drake equation. This equation uses what we know of biology, of astronomy, and sociology to give an estimate of the number of detectable civilizations in our galaxy.
The equation is a galactic scorecard. It begins with the number of stars and planets in the galaxy. How many worlds contain life, and of these, how many support intelligent life? Beings that try to communicate across the stars and live long enough to contact others without first destroying themselves. The answer is the number of extraterrestrial civilizations we could detect. When Frank Drake formulated his famous equation, some of his colleagues thought he was moonstruck. His calculations back then were mostly guesswork, based on a single example, the Earth. But when Drake dared to quantify the unknown, he changed the course of science forever.
Of course, in 1961, we knew very poorly the true values of the numbers that go into the equation. In fact, the only one we knew at all well was the rate of star formation in our galaxy. Since then, of course, we've learned a great deal.
The search for other worlds draws scientists back to the genesis of all worlds, the Big Bang, the cataclysm in which about 12 billion years ago, all time, all space, all energy, and all matter were born. From this galactic nursery came the dust and gas that would build the Milky Way, a spinning disk of 400 billion stars, among them our sun. There can be no life on other worlds if there are no other worlds. And so our search must begin with a hunt for planets in orbit around other stars. In the Drake equation, this number is known as F sub p.
F sub p is the fraction of suitable stars which actually have planetary systems. And of course, that needs to be a large number if there are going to be many civilizations to be found.
In the 1940s, astronomers believed planets were formed only in the collision of stars, an event so unlikely in the vastness of space that Earth might be a solitary island in a lifeless universe. But a new theory has replaced the collision hypothesis. As dying stars explode in supernovas of enormous energy, clouds and clumps of cosmic dust hurtle outward, only to come together later as new stars, weaving new planetary systems, just as our solar system was spun into being 5 billion years ago. Until the launch of the Hubble Space Telescope in 1990, it was difficult to test that theory from observatories on Earth. But the Hubble telescope opened a window to unknown, amazing sights. Among the most spectacular, the Great Orion Nebula, a smoggy stellar nursery 1,500 light-years away. In this Hubble snapshot, clumps of dust are condensing to form baby planets around more than half the stars in the region. To find planets in orbit around other stars across the vast reaches of space has become one of astronomy's most crucial quests. At the Lick Observatory near San Francisco, that quest has been underway since 1987. Astronomer Jeffrey Marcy is one of the pioneers in the discovery of planets in orbit around other suns.
With the invention of the telescope in the 1600s from Galileo, people have attempted to use those telescopes to detect planets orbiting other stars like the 9 planets in our own solar system. But unfortunately, while telescopes have gotten larger and larger, our ability to detect planets really hasn't improved. The reason it's really difficult to find planets is an obvious one. Stars around which the planets are orbiting are about 1 billion times brighter than the light from the planet. The glare of the star swamps the light from the planet, so you can't detect planets by directly looking at their host stars.
But as Paul Butler, Jeff Marcy's partner in planet hunting, explains, when planets cause subtle shifts in the light from their parent star, they give themselves away. Their equipment is the most sensitive ever devised.
We'd like to detect planets orbiting around other stars, and the problem, of course, is planets are very faint. You can't see them. but you can indirectly detect them because as a planet orbits about a star, it has a gravitational pull on the star, and it causes that star to make a very small counter-orbit.
And we can detect that wobble of the star by looking for something called the Doppler shift of the light from the star. As the light leaves the star and the star wobbles, the spectrum of light from blue through red shifts, and that Doppler shift of the light back and forth tells us that in fact there's a planet yanking on the star.
The search for new planets is meticulous and difficult. A Swiss team makes the first discovery in 1995. Then, a few months later, after 8 years of exhausting labor, Marcy and Butler, in January 1996, make a stunning announcement. They have found 2 planets orbiting stars much like our own sun. 47 Ursa Majoris is 46 light-years away. The planet is nearly 800 times Earth's mass. 70 Virginis is 59 light-years away, and even bigger, 2,000 times more massive than Earth.
This is kind of a golden age of astronomy because there has been literally this 400-year holy grail to find planets around other stars, and it's only been since October of 1995 that this has happened.
So now we wonder if we can find large planets. Could an alien astronomer do the same?
Imagine we are alien astronomers looking at the solar system. What we would detect is that the sun is wobbling about with a velocity of about 13 meters a second, and that one could indirectly infer the presence of Jupiter based on this. Now, this is, of course, the very crudest, earliest technique that's ever been used to find planets. One might imagine that in 500 years or 1,000 years, vastly superior civilizations, our own or aliens for that matter, might be able to detect planets simply by looking at them, might actually be able to directly see the planet, which is unfortunately beyond our technological ability right now.
But to detect a planet as small as Earth, it would take a different type of instrument. It would be necessary to build a telescope in space, an interferometer. The device features 4 linked telescopes, each trained on the same star. Their 4 light beams are combined, canceling out the star's glare, revealing the faint glow of small Earth-sized planets. An interferometer could be built near Jupiter's orbit by 2020, ushering in a new era in planet hunting. Should alien astronomers construct their own interferometer, they might be able to see the smaller planets of our solar system. They might even detect Earth's clouds and oceans. But finding planets is just the beginning of the quest. The next challenge is to find which, if any, of those worlds can support life. And most scientists agree that the first prerequisite for a living world is liquid water. But how many extraterrestrial worlds contain water? Not frozen or steaming hot, but as warm, life-giving oceans.
N sub E is the number of planets suitable for the development of life in each system. Not too close to their star that they're too hot, or so far away that they're too cold for life.
It has been called the Goldilocks zone, a region not too hot and not too cold for liquid water to exist and sustain life. In our solar system, Venus, Earth, and Mars lie within that zone. In Frank Drake's equation of life, The next crucial factor is whether planets contain the chemical ingredients for the recipe of life.
F sub L is the fraction of suitable stars which actually give rise to life. And there we recognize that there may be a multiplicity of chemical pathways by which life might first originate.
Life are born in the death of stars, aging giants that explode into supernovas, blasting oxygen, carbon, and hydrogen atoms into the emptiness of space. Atoms critical for life, the gift of stardust. It is an enormous leap from the atoms exploded from a supernova to even the most primitive of living organisms. A chain of conception so intricate that for many years biologists believed life on Earth must be a unique cosmic accident. But new discoveries have changed those odds. In the great dust clouds of deep space, astronomers have detected traces of amino acids, molecules found in every cell of every living thing. These building blocks of life are delivered to planets by asteroids, comets, and meteors. They helped seed the Earth over 4 billion years ago.
This is a ground-up piece of the Murchison meteorite. You see it's black. That means it's got a lot of carbon in it. And in this particular meteorite, we find over 70 different amino acids. And so the impact of objects like comets and asteroids could have brought with them some of the raw material we needed to set the stage for the origin of life.
But not only are amino acids made in space, they can be manufactured on planets. Planets near enough to visit. 1989, the Galileo probe leaves for Jupiter. One of its missions, to search for the chemical ingredients on the outer planets and their moons. It is a 6-year odyssey through the solar system. An odyssey that pays off with spectacular discoveries on the moons of Jupiter. There are organic molecules here, but the greatest surprise comes from Europa, a moon of Jupiter with a cracked and icy face that may hide a liquid sea. An ocean whose depths may be heated by volcanic energy. On our planet, underwater volcanic vents are home to the oldest known life forms, islands of life in the cold, dark sea. Could Europa's icy surface be hiding a cauldron of life?
It's not inconceivable that we could have a rich prebiotic soup on Europa. It's not even out of the question that we might have primitive life in Europa.
Only a visit to Europa can tell us for sure. But we do know that life began very quickly on infant Earth. Most evidence of that era of lava and earthquakes has since disappeared, except for a few extraordinary stones.
It's this rock from the bottom of an ancient ocean that we found evidence for life on Earth that is at least 3.85 billion years old. In rocks this old, fossil shapes are not preserved. So we did some detective work by examining its carbon composition.
An electron microscope finds traces of organic carbon, hinting that life on Earth began quickly.
So this evidence shows that very soon after the planet formed, life appeared. And since it arises so quickly on our planet, this might mean that life is easy to create, that it might occur elsewhere in the universe and might even be common, might even be part of the evolution of a planet, as long as you have energy sources and liquid water.
If life came so easily to Earth, it may just as easily have taken root on many worlds. In 1996, Mars provides a tantalizing clue. A 16-million-year-old meteorite, chipped off the red planet by a cosmic accident. It grabs the attention of the world with its hints of extraterrestrial life. Dr. Richard Zare of Stanford University is part of the team that examined the remarkable rock.
This Martian meteorite is special because of the strange bedfellows that we find together in this rock.
Once again, traces of carbon provide the clue. The rock appears to contain molecules left when a small organism dies and decays. The laser vaporizes the rock, and the airborne molecules are analyzed and identified. Other team members perform different tests on the rock. Electron microscopes reveal signs of what may be fossilized Martian bacteria, similar to ancient organisms on Earth.
None of these observations in themselves prove that there was life in this rock. Taken together, there's still no proof, but we have made the suggestion that for us the most likely interpretation is that some form of primitive single-celled life was in this rock from early Mars, from a time of Mars somewhere like 1.4 to 3.6 billion years ago. And the consequences of that are awesome. This rock has indeed changed my world's view, I think, and many other people's as well. There was a time that when I heard talk of extraterrestrial beings, I thought that I was dealing with perhaps some type of kook or nut, or somebody who really enjoyed science fiction. It's not something that a reputable science would have much to do with. I think now many scientists are taking seriously the possibility of extraterrestrial life, not only on Mars, but maybe on other planets that circle and orbit other stars. Maybe the universe is teeming with life.
Spurred on by the breakthrough, NASA is planning to send 10 robotic missions to Mars in the next 10 years. The first mission, a rover called Pathfinder. In 2005, a probe will collect Martian soil and bring it home to Earth. Proof that bacteria once lived on Mars, or a discovery in the oceans of Europa, would drastically change the odds of life in the universe, an indication that life may be common. But the yearning within us seeks more than primitive organisms. We seek intelligent beings to contact, a civilization beyond the stars that thinks and dreams. To Frank Drake, the enigma of intelligence introduces the next variable into the equation of life.
F sub I is the fraction of systems of living things which actually evolve intelligence. We wonder about that. How often do creatures like us really appear?
I don't think that it's inevitable that a human-like intelligence would evolve on any planet, because I don't think any particular organ inevitably evolves on this planet or anywhere else. I think there's an old idea that intelligence is somehow the culmination of the evolutionary process, that organisms have some internal drive to unfold into more and more complex forms, culminating in human intelligence.
Well, let's compare our kind of intelligence with other things that have evolved once or more on this planet. There are many good tricks that are very useful. The elephant's trunk good for many different things, not just for one thing. Our kind of intelligence looks at first very quirky. It's only evolved once on this planet. Supposing our species simply blows itself up and we go back to a bacterial world, what might happen next? Well, it would start all over again. We'd have bacteria, and we might then get multi-celled creatures after another billion years, and it might be this time as something for a mollusk-like thing. Maybe the octopus would be the progenitor of the intelligent species then, or something bird-like. Maybe another time it would be the descendants of ostrich-like things, which eventually held the chairs in universities and governed the democracies of another civilization 10 or 20 billion years down the pike. So the idea that evolution might yield quirky human-type intelligence with culture and language again and again is not so outlandish.
If intelligence is inevitable, what might intelligent aliens look like?
Well, if we use our own planet as a guide, I think we can expect that intelligent aliens, first of all, are going to be mobile. They're probably going to be symmetrical, because symmetry is just much more efficient if you're going to be mobile. They're going to need distance perception, so they're going to have something like eyes, probably ears as well, perhaps noses. They may not be arranged in the same way that ours are. They may not have one organ, a mouth, which is used for both communication and for eating. So we would expect them to be, in many regards, recognizable as living, intelligent beings.
There may be many intelligent life forms in the universe, but to find them, they must possess the technology to place a phone call across the galaxy. The ability to place that call is the next crucial condition in the Drake equation.
F sub c is the fraction of systems of intelligent creatures which actually develop high technology which we might detect one way or another across the great distances which separate the stars.
Earth reached that stage 60 years ago. Our signals started leaking into space via radar, radio, and Sid Caesar.
Remember Caesar and Coca in the show of shows?
We do broadcast inadvertently. Our TV signals sort of leak off the Earth and go into space, and I Love Lucy has already reached out to a couple of hundred nearby stars. So if there's an ET around some of those nearby stars with a big antenna farm somewhere, maybe he's watching some of these early TV broadcasts.
And for the past 30 years, we have been listening for alien broadcasts. Giant radio telescopes scan the distant stars and galaxies in painstaking search for extraterrestrial intelligence. Known as SETI, it listens in on billions of channels for one unmistakable wake-up call from outer space.
There are really two kinds of signals that SETI researchers look for. On the one hand, it could be that ET, for reasons known only to him or her, is deliberately targeting Earth with a signal, sending a rather powerful beacon our way to say, hey, look, here I am, join the Galactic Club or something like that. That would be an easy signal to find. But another possibility, of course, is that we may eavesdrop on signals that ET is broadcasting for his own purposes, internal communications. They might be harder to find because they presumably would be weaker, but there may be a lot more of them.
To give an extraterrestrial a hint about our species and an invitation, Frank Drake composed a message to be beamed out to the stars. It was transmitted in 1974, a depiction of our solar system and of us. A message that may have already been intercepted and understood. But one question remains. Can an alien civilization survive long enough to send a reply? This is the last variable in the Drake equation.
L is the lifetime of civilizations in a detectable state. And of course, when you think about this, you realize that When civilizations are capable of doing this, they're also perhaps capable of destroying themselves. And we wonder, how often does that happen?
New technology will soon allow us to search for other surviving worlds. We begin to calculate Drake's equation with increasing precision. The result of Drake's calculation is astonishing. There may be thousands of intelligent civilizations in our galaxy alone.
If we use the best values we now have for the numbers that go into the equation, one can estimate that the number of civilizations, N, is something like perhaps 10,000 or maybe even 100,000 in our galaxy alone. And of course, that's a large number. It's very exciting. But nevertheless, when you take into account that there are perhaps 200 billion stars in our galaxy, it means we will still have to do a great deal of searching before we succeed.
This would be the greatest discovery of all the ages. Beings who may have already begun to voyage beyond the stars, plotting a course for Earth, setting the stage for what would be the greatest revolution of all: first contact. It is an encounter that many on Earth believe has already occurred. 1947. North Americans suspect they are being visited by spacecraft from another world. That summer, in the Cascade Mountains of Washington State, an amateur pilot named Kenneth Arnold sees 9 disc-like objects that move like stones skipping across a pond. One clever reporter labels them flying saucers. Arnold's sighting sets off a chain reaction and an Independence Day unlike any other in American history. The sightings will amaze and terrify citizens, the military, and government officials. From New York to New Mexico, people report strange discs streaking through the clouds. In Seattle, a Coast Guard official photographs one of the mysterious craft. A United Airlines pilot in Idaho records a squadron of unidentified flying objects flanking his aircraft. When the pilot meets Kenneth Arnold, they soon agree that aliens have been visiting the Earth. At first, the Air Force is skeptical, but by the fall of 1947, military pilots have begun reporting their own sightings of strange craft. And the Pentagon fears the discs are either strange new super weapons from the Soviet Union or spaceships from beyond the solar system. The military initiates projects known as SIGN, Grudge, and Blue Book. Even the CIA gets interested. The Air Force begins an investigation that will drag on for 20 years, including cases in which American pilots are killed trying to chase down suspected UFOs. Yet publicly, the Air Force tries to convince witnesses that they have seen nothing more mysterious than meteors known as bolides.
All right, good, fine. Now, but have you ever seen a real bolide? Oh, I've seen them up high in the sky. I've never seen one close, no. Also, may I ask one question on a meteor? Don't you think it would be kind of unusual for a meteor to just fall across the road and hover over there a minute and then drop to the ground?
The coming over wouldn't be bad. It's the hovering that would bother me. This is why I wanted to know just how long it hovered.
Yes, well, it hovered too long to be a meteor. Excuse me for saying this.
No, it's all right. This is what I want to find out.
Some sightings may be glimpses of American military planes, but secretly, the Pentagon worries that an enemy nation has created a completely new type of aircraft. By the late 1950s, the Air Force is declaring publicly that there is no such thing as a spacecraft from another planet, while it tries secretly to launch a flying saucer of its own, a Canadian-built hovercraft called the Avrocar that never quite gets off the ground. To prevent public hysteria, the Air Force makes an official announcement.
There has never been any evidence presented to the United States Air Force or discovered by the United States Air Force which would indicate that the UFO phenomenon represents any interplanetary space vehicle of any kind.
UFOs are laughed off as swamp gas, meteorites, or weather balloons.
In the imaginative mind, the saucers took on weird shapes and forms. Rumors grew that they might even be fantastic invaders from another planet. But now they tell us it was just a lot of balloons.
But official denials do little to quell public opinion. For decades, believers have looked to the skies, while scientists refuse to entertain the idea of alien contact. But one prominent physicist does give the question serious consideration. Enrico Fermi, an architect of the atomic bomb. In Fermi's view, the universe has been evolving for more than 10 billion years, long enough for thousands of life forms to have set out to explore the galaxies, long enough for one of them at least to have visited the Earth. In the 1940s, Fermi is emphatic. Aliens have not visited our planet because aliens do not exist. But 50 years later, astronomers and biologists are not so pessimistic.
I've never been particularly impressed with the argument, the Fermi argument, that if there's intelligence out there, where is it, why haven't we discovered it yet? It's early days in the universe.
We are just impatient. We feel that as soon as we have reached the stage of communication, they should be doing something.
I think the reason that we haven't seen other life forms is that they're not on such a different schedule from ours, and we aren't able to do it yet, and so probably they aren't too.
It's quite possible, for example, that some extraterrestrial civilization may have tried 100 years ago to communicate with us, and that would have been premature because at that time we didn't have television or any other means of making communication. So they may not try us for another 100 years.
To contact us, to travel to our Earth, an alien spacecraft would have to conquer technological problems that boggle the human mind and push the limits of our scientific imagination.
build a spacecraft that travels at the fastest speed known in nature, the speed of light.
There's nothing in nature, there's nothing in physics that prevents us from doing interstellar missions.
An alien civilization may already know about Earth from our radio and television signals. But before setting out to visit our solar system, they might send a robotic probe first, a scout, to tell them about our world. Unmanned spacecraft sent from Earth have been investigating our own planetary neighborhood for the past 20 years. Reliable and inexpensive robots would be the likely choice of curious aliens. The behavior of an alien probe is already the subject of scientific speculation.
A probe that had to come to our solar system and make contact with us wouldn't need to be as big as one that carried an astronaut. Something perhaps the size of a human head would be big enough. We could pack into an automatic probe of those dimensions everything that would be needed to communicate. Enough memory, enough programming, micro-miniaturized circuits, and when it arrived here, it would be equipped with its TV receivers all ready to make contact with us.
The probes might be mechanical or an advanced computer capable of reproducing itself.
If an alien probe were coming through our solar system unannounced and wanted to get our attention, it could do that very simply by listening to the television programs that we're transmitting and repeating that back to us, amplified, and then we would see, as we looked at the TV, the program we were expecting, followed a few moments later by the same thing, displaced a little on the screen, perhaps a little fainter, but it would be so unusual to us, we would know immediately that something strange was out there, just exactly what the probe was trying to achieve.
An alien civilization might also make itself known by sending out signals. Listening for alien broadcasts is the goal of SETI, the search for extraterrestrial intelligence. A search inaugurated by the pioneering astronomer Frank Drake.
I started the modern radio searches for extraterrestrial civilizations in the year 1960 because at that time our improved telescopes and radio receivers made it possible for us to detect signals no stronger than we ourselves were radiating across the distances which separate the stars. And so it was possible and reasonable to search for what could be the most important discovery ever made.
Today, the most powerful receivers ever built scour the skies. The SETI project has been given new relevance by the recent discoveries of planets orbiting distant stars, hinting that our Milky Way galaxy may harbor hundreds of millions of worlds still unseen. Today, Drake is joined in the search for ET's phone call by a new generation of astronomers, Seth Shostak.
One of the exciting scientific discoveries of the past year that has really influenced what we do, of course, is the fact that other stars have planets. It's always the question, does ET really have a home to phone? Well, now we know he probably does. So that means that there are literally tens of thousands of billions of other planets just in our galaxy. And that's obviously extraordinarily encouraging for the kind of work we're doing.
Shostak's telescope targets specific star clusters that could be likely candidates for the origin of a signal. But another method, a wide sweep of the entire sky, is favored by Darren Lee of Harvard University.
We're looking for a beacon from an extraterrestrial technological civilization, basically a signal saying, hello, we're here, this is unmistakable, please talk to us. To do that, we need to make sure that the signal is A, artificial and not natural, because there are a lot of natural sources out there in space. We don't want to get confused with those.
Space is a noisy place. Stars, galaxies, supernovas, even black holes constantly emit crackles, pulses, and static. SETI researchers try to isolate manufactured messages from the background din.
To make sure that the signal is actually artificial, we're looking for pure tones, a sinusoid, like a whistle sound. It turns out that nature can't make these very easily, but it's very easy for us to do with a radio transmitter. The second thing we're looking for is to make sure that these are actually from outer space and not from Earth.
Earth also produces a racket of radio noise. Military, radar, and satellite transmissions must be ruled out before any signal can be classified as indisputably alien. So how do SETI astronomers rate their chances of success?
Many people ask, well, when is this going to succeed? Obviously, I don't know. No one knows, in fact. This is a bit like asking Chris Columbus 2 weeks out of Spain, when are you going to discover a new continent? I mean, it might be this afternoon, and it might be never. He doesn't know. We don't know. But the equipment is getting much better rather rapidly now. About every year, the equipment doubles in capability, and usually when you have a situation like that in astronomy anyhow, you normally make discoveries within 10, 20 years. So maybe that's a good number, but it's highly speculative.
The signal were to be received, we need to follow up on that very quickly, and fortunately the system is set up to do that almost completely automatically. What will happen is, first it'll look at the original signal that it received and see if it meets certain criteria.
The telescope will swing away from the source. If the signal vanishes, it must be coming from one single point in the sky.
If it passes those sorts of tests, then at some point you'll call up a colleague at another radio observatory and say, you know, Marvin, sorry to disturb you, but we've got something here that's looking very interesting, and would you mind turning your telescope on it, because you want to rule out the possibility that you're just monitoring a bug in your system, local interference, a Caltech undergraduate prank, something like that, okay? And only if it's confirmed by somebody at another observatory would you say, all right, now it's time to tell the world, and you would.
That announcement would change the world forever, banishing our solitude, placing us within a community of living, thinking beings. That first signal would be comparable to the ringing of a telephone. But to actually hear the phone call, powerful new receivers would need to be built. Then the work of code breaking would begin, and mathematics might provide the key.
Well, suppose we get in touch with them and we want to establish communication with these aliens. And one of the things we're going to find is that they have arithmetic. Why? Because arithmetic's the same throughout the universe and for all time. It's just one arithmetic. They should share mathematics with us and a great deal of our physics, of course, probably all of our physics.
Simple arithmetic might lead us to comprehend an alien language.
Decoding an alien language would be much harder than decoding the language of some other human group. All languages on planet Earth are pretty much built out of the same plan. All languages have words that are combined into phrases using distinctions like noun versus verb or subject versus object. And so when you come across an exotic human language, you can be pretty confident that you've carved it into the right kinds of bits.
But even some human languages are almost impossible to decode. Egyptian hieroglyphics were a mystery to archaeologists for decades. And Mayan symbols have been frustrating researchers for over a century. An alien language might take even longer to decode.
For a language from an alien, on the other hand, coming in on a radio broadcast, it would be much tougher. It would appear without a context. It would just be a bunch of signals, and you'd have to do something more like cryptography.
But it might be easy if aliens understood reality as we do. A world full of brightly lit objects, buildings, clouds, planes. But if they evolved on a truly alien world, their words and thoughts would be alien too.
Imagine that an organism evolved in murky water or in caves or on a dark planet, they may have a hyper-developed auditory sense, a sense of hearing, and maybe that would have been elaborated in their evolution to be the foundation for abstract thought. And they may use all kinds of sound effects instead of blackboards and books in order to convey abstract ideas.
To encourage an alien response in a form we could comprehend, scientists sent out a calling card in 1974 from a radio telescope in Puerto Rico. It was a coded snapshot of our species and our address in the Milky Way. To receive a similar message from space was the fervent wish of the founder of SETI, Frank Drake.
When the day comes that we actually detect a signal from another world, there'll be a series of impacts on Earth. First, there will be excitement, great excitement over this discovery, and questions. What is it? What are these creatures like?
It would show that we are not intellectually unique in the galaxy. I mean, mankind has the tendency to think that he's very special. We consider ourselves morally, culturally, or intellectually unique. But if we were to find a signal from another star system, from another thinking being, we would know that none of that is true.
A signal from space would change history, requiring us to learn whether deep space travel really is possible. This is the next challenge in our quest for life beyond the stars. But interstellar travelers face a journey of epic proportions, an odyssey that promises to last decades, even centuries. And the first challenge is gravity. To defeat it on Earth requires powerful rockets, such as the ones that launched the Voyager probes, to the escape velocity of 24,000 miles an hour. Why do probes, such as Voyager, need to travel so fast? Physicist Lawrence Krauss, author of The Physics of Star Trek.
It all started with a simple apple. 300 years ago, a monomaniacal insomniac named Isaac Newton saw one of these fall from a tree. It didn't hit him on the head, but it gave him a fantastic idea. He realized that the apple falls to Earth more swiftly than the moon does, simply because it's closer to the Earth. And that means that the Earth's gravity gets weaker as you get farther away from it. Newton's idea was revolutionary and helped explain why Voyager had to travel at least 24,000 miles per hour, because that's the speed it takes to completely escape the first heavy pull of the Earth's gravity. It's called the escape velocity. And it doesn't matter whether you're launching a space probe or an apple, nothing less than 24,000 miles per hour will do if you want to escape from the Earth's pull.
At that speed, a flight from New York to Los Angeles would take only 5 minutes. But Voyager's assignment is to examine Jupiter, Saturn, and the outer reaches of the solar system. And in cosmic terms, our fastest spacecraft is tortuously slow. It takes Voyager nearly 8 years to reach Uranus. At this pace, a trip to the nearest star would last nearly 80,000 years. The immense immensity of space staggers the mind. At Voyager's speed, the closest known planets are hundreds of thousands of years away. An expedition to the edge of our Milky Way galaxy would take longer than the entire history of the human species. To conquer time and space, engineers at the Jet Propulsion Laboratory in California are trying to design power systems that could shrink an interstellar journey into a single human lifespan.
What does the future hold? Well, when we look towards doing interstellar missions, we're inevitably faced with the requirement for extremely high power systems and incredible amounts of energy. A typical interstellar mission is going to require a propulsion system, a machine that produces power at least 3 times what all of humanity currently produces. For example, when the Saturn V took off to go to the moon, it was producing power at a level corresponding to 0.5% of all the power produced by humanity in 1969.
To blast off for our moon, the Saturn V rockets needed to burn fuel for only a few minutes. But an interstellar mission would require much deeper reservoirs of power. Designing these propulsion systems of the future is the work of visionary scientists inspired by the nuclear fusion reactions that light up the stars. If this energy could be harnessed, it might provide enough power.
One way of harnessing the energy from a fusion reaction is to use a concept known as the Orion vehicle. In this concept, you drop a small fusion bomb out the bottom of the vehicle, which explodes and then pushes against a physical pusher plate at the bottom of the vehicle. Because of the extreme violence of the fusion explosion, you can't just have it pushed directly against the vehicle. Instead, you have a series of shock absorbers that take up the force of the explosion and then push the vehicle, including its payload at the top.
But even at 21 million miles per hour, it would take 140 years to reach the nearest star. If alien explorers are cruising the galaxies, they must have developed propulsion systems even faster than nuclear-powered ships. Their goal would have to be the speed of light.
All these spacecraft travel at a relatively slow speed throughout the galaxy. So why not build a spacecraft that travels at the fastest speed known in nature, the speed of light, 186,000 miles per second? But beyond the daunting fuel requirements, once one enters the domain of light speed, one leaves behind Newton's world and enters Einstein's domain. And in Einstein's theory of relativity, all the constants of Newton's world, space, time, matter, become relative. The only remaining constant is the speed of light. It's a whole new world with new rules. And the most important rule of all is that the speed of light is a cosmic speed limit. Nothing can exceed it, and nothing with mass can even reach it. Not anything as small as an electron or as big as a spacecraft. And that's the problem, because space is so big that even the speed of light, which is as fast as it gets, is a pretty slow way to get across it.
At the speed of light, it would take barely a second to reach the moon. "5 hours to Pluto, 4 years to the nearest star. a journey that human beings might attempt except for one problem. Albert Einstein proved nearly 100 years ago that light speed is impossible to attain. At JPL, designers are trying to find how close they can get to the speed of light.
Anytime we start dealing with interstellar missions, we inevitably have to face the problem that these vehicles are going to require very high power levels and enormous amounts of energy to reach speeds near that of light.
It is a cruel cycle. More power means more fuel. To overcome Earth's gravity, the space shuttle carries fuel that weighs 200 times more than the shuttle itself.
One way to get around this problem is not use propellant at all. We can do this when we beam photons to the vehicle and use photons or particles of light as our propellant. This is called the laser light sail.
The sail's power source is a star. The light is collected to create a powerful laser beam. A beam that is directed by a gigantic lens. Projected onto a thin sail, the size of the state of Texas. The pressure of the laser accelerates the sail to fantastic speeds. It could reach half the speed of light, making it the most likely candidate for interstellar missions. Fitted with a crew compartment, it might be the motorway to the stars. The journey would still be long and perilous. The huge sail would encounter small comets and chunks of rock, creating explosive impacts. An army of repair drones might be needed to keep the fabric intact. But is the laser light sail the fastest possible way to travel the universe?
Ironically, it was Einstein who may have provided a loophole. In 1915, he proposed a radically new way of imagining space, time, and gravity. He proposed, in fact, that space and time are curved in the presence of matter. Imagine that this apple is a star. Einstein showed that massive objects like stars make great dents in the fabric of the universe.
These dents are called gravity wells, folds in space that might provide a shortcut through space and time. Diving through these so-called wormholes, voyagers might suddenly leap across the galaxies. But these might be one-way passages, a plunge into the unknown.
So we're stuck in a sub-light-speed universe, where even a voyage to the nearest stars would take decades, if not centuries, at an enormous cost. However, while the impossible can never be made possible, there's still a lot of physics yet to be discovered. Whether or not aliens even exist, and if so, whether they've overcome the enormous obstacles to venturing outside their home solar systems, are questions that no one can answer, yet.
It is possible that an alien spacecraft may already be on its way, watching us from the outer limits of our solar system. If it is en route, its crew will find our planet and our scientists in the midst of a revolution. After years of wondering if we were the only thinking, intelligent beings in the universe, we are turning our minds and our eyes outward in search of intelligent beings. Since 1995, astronomers have amazed us with the discovery of planets outside our solar system, leading us to wonder how many millions of worlds await our detection. Worlds that may be home to beings intelligent enough to be searching for us. A revelation that to astronomer Paul Butler is the stuff of dreams.
As we stare out at the stars at night and we're trying to detect planets around these stars, there might well be alien astronomers on any one of these planets looking back at our solar system and attempting to detect Jupiter or Saturn.
Today, pioneering astronomers have been joined by biologists and chemists who suspect that the universe may be teeming with life. Among the cornerstones of this new thinking is a meteorite from Mars that may contain fossilized bacteria. One of the scientists who has examined it is Dr. Richard Zayer.
I believe scientists are thinking hard about the possibilities of finding life out there beyond Earth, of looking at extraterrestrials all over the place. If Mars, then why not on other planets that orbit other stars?
No one knows how many planets might be the homelands of intelligent beings. Astronomer Frank Drake has formulated an equation that leads us to a possible answer.
If we use the best values we now have for the numbers that go into the equation, one can estimate that the number of civilizations, N, is something like perhaps 10,000 or maybe even 100,000 in our galaxy alone. And of course, that's an exciting number. It means there's something there to be found.
But would a superior civilization consider the Earth worth visiting?
If the extraterrestrial civilization that we're imagining is as advanced as we say, why would they want to come here in the first place? Well, I think they would have the same scientific curiosity about new discoveries of life in the galaxy that we have shown with our own efforts to explore the geography of the world, to explore the Moon and Mars.
Astronomers have already found a handful of extraterrestrial star systems that look like candidates for contact. Lalonde 21185 has one large planet and possibly a number of smaller planets that might sustain life, only 6 light years away. Using a laser light sail, travelers from Lalonde 21185 could accelerate to half the speed of light, embarking on a journey that would take little more than a decade. Far outside our solar system, the alien ship would have to slow down. The laser light sail would separate into 2 parts. One half would reflect the beam backwards, pushing the capsule into reverse. Targeting our planet, they would find many human beings already believing in extraterrestrial life. But would we see them coming?
One question we always ask is, would we be able to detect an alien spacecraft approaching the solar system? And the answer is very probably. There are lots of different astronomers looking in lots of different regions of the electromagnetic spectrum. And almost any propulsion system you can imagine would show up. It would be quite bright. For example, if they used a nuclear system, they might detect neutrinos, neutrons, or other forms of radiation. If it's a laser light sail, we'd see the laser beam as they slowed down to approach the Earth's sun.
To maneuver within our solar system, our visitors would transfer to an exploratory module. It could take this smaller, slower ship up to 2 months to fly past Saturn, Jupiter, and Mars. Time enough to become headline news all over the world. For an alien traveler, this would be the moment of revelation, the first orbit of our small blue planet, the end of a truly cosmic quest. Each movement of the approaching capsule would be monitored by radar installations established during the Cold War, built to track every satellite and scrap of space junk. Military aircraft might be scrambled before the alien craft entered the atmosphere. After decades in flight, the wanderers would search for a place to land, a place that perhaps has been expecting visitors. For the first indisputable contact, it might be fitting if our visitors selected a quiet little town that has been scanning the skies for generations. A town like Roswell, New Mexico, where a return visit seems about 50 years overdue. A visit that would satisfy the deeply human desire for contact with an alien species. Finally and eternally, we would no longer be alone.